Welcome to Signal Pass. I'm Doug.
And I'm Ryan.
And today we're going to be covering the topic of switch mode power supplies and why they have came up in the world of high-end audio and are now a viable source of power.
Viable choice.
Okay.
Yeah. Well, before we get into this discussion, we need to address something.
Oh, yeah.
Apparently, and it was actually pretty obvious on the video, apparently Doug and I tend to do this, and we rock back and forth. And Walter, I don't know who Walter is, but Walter commented that he was getting motion sickness. So Walter, I'm sorry.
Yeah.
We are going to address this and try to stand a little bit more still. But
to our defense, we did rock in unison.
Yeah.
Because audiophile's no rhythm.
That's right. That's right.
And
it wasn't a dance.
No. And I mean, a little Rain Man and never hurt nobody, but
yeah.
We'll try to work on it.
Yeah. So anyway, if you have any other critiques like that, please let us know. And if you can deliver it in a way Walter did, which was to make it funny without being insulting, that's great too.
Great.
So,
I love good comedy.
Anyway, yeah, we appreciate you, Walter. And we appreciate all of our viewers.
Yeah.
So,
Oh, yeah.
Anyway, yeah. So back to switch mode power supplies. This is a topic that kind of came up as a result of discussing how Constellation came into our brand lineup.
Mm-hmm.
Because I think I was telling you, when I auditioned Constellation Audio, I auditioned them while they were still using toroidal transformers, which is a linear power supply.
Right.
And I loved them. And they weighed about 130 pounds. And so, anyway, when I ordered them, they were in a transition period. And I knew they were in a transition period. They were like changing some stuff. Like I'm basically told they're changing stuff. Right. And one of the things that popped up as I'm looking at things as like shipping manifest or whatever, like it really was a glaring thing. It was like, oh my gosh, the weight it's not half, but it's close to half. It's a little bit over that, but it's one the weight. And I was like, well, then something happened to these transformers. Like
right.
Something
changed.
So I called Irv at Constellation Audio, and Irv is such a cool guy. If you're an audiophile, you've been going to Expo and stuff like that, make sure, or any other big audio show or Constellation, you got to stop by the Constellation room and talk to Irv. Irv is a friend to all, and he's an amazing individual. So anyway, I call Irv, and Irv said, listen, Ryan, I wouldn't send you something that was not going to perform as well as what we had. And he said, we made this change because we improved what we were doing. And so I was like, all right. He goes, I promise, you'll get your money back if you don't like this. It's like, okay. So I went ahead and got the amp, and it delivered in a huge way. It was awesome. So, yeah. So I guess the question is, switch mode power supplies had a bad reputation for a long time.
Well, yeah, throughout history,
yeah.
I mean, they were used in small devices, cheap devices. That was the power supply of choice for cheaper devices. And it wasn't until the last several years that technology has caught up to the point where they can make them, they can control them to where they're as good, as viable, and sometimes a better choice than a linear power supply.
Okay. So why did linear have like this great reputation of being so much better than like how? I mean, linears haven't gotten worse. They're still great. Yeah, they haven't changed. So what?
Yeah.
What was so much better about them versus the switch?
Well, I mean, the linear power supply, the original toroidal version of linear power supply, is something Cambridge Audio came up with years and years and years ago, and it's not computer controlled or anything like that. It's a toroidal transformer and then a filtering capacitor bank that stiffens the power from the toroidal transformer and filters it, or cleans it up. And it worked. It worked well. And switch mode power supplies were kind of regulated to cheap devices. Well, what they found was that controlling switch mode power supplies, microchip controllers got better. Everything got better at controlling the high frequency switching of a switch mode power supply, and the parts got better to the point where now they can create a switch mode power supply that is actually as cleaner than any linears are.
Okay, so clarify that a little bit for me when you talk about controlling the high frequencies. Is that what you said?
Yeah,
Sorry.
switch mode power supplies are kind of like Class D amplifiers, and they switch at a very high frequency, very fast. And the side effect of that is that if they don't push that switching frequency way high, it can affect the upper frequencies and the frequency band of
So
audio.
if it's in the 18,000
yeah. I mean,
range,
if
gonna
it's
be heard.
switching, well, a lot of times if it's switching close, it's still higher than your upper limits of hearing.
Right.
But if it's within a certain, it's close enough. Artifacts from that distortion, that switching distortion, can make its way to the lower frequencies.
So they had to send that way high.
They had to get way
like
faster.
How high
with
are we
it.
talking?
Megahertz sometimes.
Megahertz.
Yeah.
Okay.
But and before that, they didn't have the technology or the parts to do that. Now, with some of the newer parts out there, they've got the ability to do that.
Okay.
That helps quite a bit. Plus, the switch mode power supplies have factors that are controlled. They have basically computer-controlled factors in them for this switching and the regulation of power and stuff like that, and those controls have gotten better. So through these whole processes, what they found was switch mode power supplies can be made just as clean, if not superior, in some ways to linear power supplies, especially in efficiency.
Okay, very cool. So you talked about the word clean. Okay, when we talk about clean, I think we're talking about noise floor. Is that right?
That's a part of it, yeah.
So,
Low distortion, noise floor, yeah.
All right, so the enemy of any amplifier or any audio system, like not just the amplifier, but the musical signal, the enemy of that is going to be noise. And so when we're talking about noise, we're talking about distortions.
Correct.
Right?
Of different types.
Yeah. And so, when we look at, Constellation's kind of dug into this power supply thing, and they've figured it out. Like theirs is like 20 dB lower than a conventional linear power supply.
Correct. They use a switch mode power supply that they developed with their controls, and then after the power supply, they put it through a power factor correction, which cleans it up even more.
Okay.
And keeps phase aligned and everything. So the output section is receiving a pristine signal, which is a big, important thing in power amplifiers.
Now, do you think you've got an idea as to like what they've done to these power supplies to get them so cleaned up? With
I'm not going to even try to.
Not even going to try.
No,
Okay.
I mean Constellation engineers are smart fellas. They I don't want to butcher it, so I'm going to.
All right. We'll leave
those
that
questions,
to them.
leave that to them.
All right. And when I was growing up, like my audio dealer guy up in Kansas City, his name was John Clark. I remember when we asked him certain questions like that, he would just go, "It's magic." And so this is some of that magic, but we know there's a lot of great engineering.
It so happens that some of it these guys live and die by the mathematics of designing circuits, and they understand that the majority of the public wouldn't get it if they tried to explain it. So they don't even try.
All right. So what are some other things that are going to? You talked about power factor correction. What is that?
Power factor correction is basically a smart version or a smart way to see what's incoming power wise and make any corrections needed to keep phase aligned, to keep the power clean and stuff like that. So the output section's getting the right phase signal and a clean signal. And it keeps regulation. It regulates the power so everything stays within the realms of what it needs to be. Okay, that's a simple way of saying.
Yeah, and so one of the things that we see, we're gonna plug Constellation here. Sorry, shameless plug. One of the things that we see as we're looking at Constellation, keeping things in phase. Their modules are built such that you have essentially the same module for the positive signal that you have for the negative signal.
Yeah, quite a bit of the amplifiers out there that are dual differential, they they use an amplifier module on the plus and an amplifier module on the negative side.
Okay.
That's what's called a balanced amplifier.
Okay.
An unbalanced amplifier only has it on the positive side.
Okay. Right.
That's why a lot of balanced amplifiers are higher in cost,
Right.
because you have to double up parts.
Uh-huh.
But Constellation goes even a step further and uses exactly the same transistors for plus and minus. Instead of doing an NPN and a PNP, which is positive, negative, positive, or negative, positive, negative, they use N-types all the way around. So it's the same exact parts doing the same exact thing, just reversing the phase of the negative side. And they call it dual differential because anything different between those two signals gets thrown out.
Okay.
And that's
Very
where
cool.
distortion minimizing.
Very cool. Yeah. So it's just a really well built.
Overall,
and
yeah.
honestly, we can sit here and go, well, what would it have sounded like if they put PNP on the other side? We don't know.
No, I'm not the engineer of it, so I have no idea.
So,
they had a reason to do
yeah.
it, and I'm not going to argue with them.
What we know for sure is they sound great.
Yeah, and the thing I like about Constellation too is the fact that, and I've looked at their statement series, their performance series, and then the series we have here.
Mm-hmm.
Every one of them, they're built with the same parts. They're built with the same modules. It's just as you stepped up the line, there's more of them.
Yeah.
And the power supplies get bigger because as you move up the series, the power gets way more.
Yeah, so what's interesting about that, you'll hear people talk about, if you've got the ideal amplifier, you build it this way,
Mhm.
right? But if you've got to make it for less money, you have to compromise in some way,
Mhm.
right? This is almost like the only thing you're compromising on is the amount of power.
That's it. That's what I like about
Like
it.
the whole design, whether it's their $150,000 design or their $30,000 design or even their $15,000, $20,000 design, they're using the same circuitry but less of it.
Yeah,
Right?
It's basically
so fewer transistors, as
Right.
opposed to I don't know how many transistors they're actually using, but let's say it's 20. They might have 20 on this one, but they might have 50 on this other one.
Yeah, it's
whatever.
Yeah. Some brands they'll as their series change, they use lesser quality parts in their power supplies, cheaper transistors, cheaper resistors, cheaper capacitors. Constellation doesn't really do that. What they do is their statement series has a huge switch mode power supply and several modules to make up that huge power.
Yeah.
Then, like the Revelation series here has a smaller power switch mode power supply and 4 sets of modules or 2 sets of modules to power the differential drive.
Yeah.
So you're not losing quality; you're just getting a lower powered version.
Right, exactly. So it's really just a great company to say, okay, we want quality at every level.
Well, they're giving their customers the same ability for minute details, sound character, and tone, no matter how much you have to spend.
And it's just a different amount of headroom.
It's a headroom, and depending on how much power you need for your speakers and how big your room is.
Yeah, absolutely. So that's very cool. Well, I think we did less of this, so I hope so. Let us know.
Yeah.
We always have different ideas for topics that are going to be coming up, but we definitely want your input. What are some topic suggestions that you have? Like, what questions do you have? What is missing in your audio knowledge? That's where
there's anything that you want to know about, let us know, and we can do some research on it and get back with you and do a whole video on it so you can get a better knowledge base, because the best high-end audio customers are the people with the knowledge to know what they're shopping for.
Absolutely. So he's Doug. I'm still Ryan. This is Signal Paths.
Yeah.
And we'll see you guys next week.
Yeah.
Doug, I almost forgot. You got a project going on.
I do.
What's going on, man?
I'm custom designing a set of new speakers that I'm going to be coming out with.
Oh yeah.
Mm-hmm.
What kind of design?
It's
Don't give them too much. Like, we don't want to give them your proprietary technology.
Yeah, it's open baffle and horns.
Open baffle and horns.
Yeah.
Very cool.
Traditionally, everybody has this certain thought about open baffle and a certain thought about horns, and I'm trying to turn that on its head.
Very cool, man. So we've got a couple of pictures we'll be showing up here on the
just
screen.
Pictures of me. In fact, I worked on them outside yesterday just because I like outside when it's nice.
Yeah,
And so I took them outside.
I called
and
you
worked on it.
yesterday, and I think you were probably covered in sand because you
Yeah,
were sanding. Yes?
sanding.
All
Yep.
right, very cool.
They're going to be. I'm doing a little bit different on the way I'm building them, and then, like I said, I basically want to take the concept of open baffle and horns and allow people to hear that those two things can work harmoniously together and sound beautiful, and you don't get none of that horn honk and stuff that people traditionally think of.
Nice. All right, cool. Well, we're looking forward to seeing what your product looks like, but also
Sounds like.
that's what we're really looking forward to.
So stay tuned because I'll have more information about them coming up.
All right, more signal paths next week.